It's Friday. All right, today we're going to talk about piecewise defined functions. So I made some notes so you can print those out if you'd like to follow along. All right, so very simply put, so we can fit it in a 15-minute video, a piecewise defined function has different rules for different parts of its domain. Literally, we're just going to graph one function that has two separate pieces or more, okay? So what we're going to do first is on this one, I've given you two different boxes. I do recommend just doing a table. It's the easiest way to graph these. You can do it other ways, but this is the easiest way. So I'm just going to graph f of x equals 2x here, and I'm going to graph f of x equals x plus 1 here. So all I've done is I've split this function into two parts because it has two parts. All right, so to pick which points you're actually going to use, you're just going to go up here to this restricted domain. So this says if x is less than or equal to 0. So in the 2x function, I'm going to go over here, I'm going to put a 0. Then I'm going to pick numbers that actually satisfy less than or equal to 0. Well, less than or equal to 0 would be a -1, a -2, and a -3. Depending on the numbers, you might need to choose fractions or whatever, but this guy, he'll fit on the graph I have given. Okay, to do this, you just plug in 0. So plugging in 0, 2 times 0 is 0, 2 times -1 is -2, 2 times -2 is -4, and a -6. So I now have all those ordered pairs. Next, I'm going to go over to the second part of this piecewise defined function, the second piece of it, and look at these restricted domain here. Okay, common mistake. People say you can't use 0 because it's not equal to 0. I am always going to use the number that I give you here because 0 is not included, but I need to put an open circle there. So I do need to have something, because if you just straight start at 1, then you've missed things that are greater than 0 are a half and 0.2 and 0.1 and 0.005. So if you start at 1, you've missed an infinite number of numbers there. So always start at the number I give you, whether it's included or not included, and then I'll talk about what to do with those in just a second. All right, so numbers that are greater than 0 are 1, 2, and 3. And we're just plugging in 0 into this function here. So 0 plus 1 is 1, 1 plus 1 is 2, 3, and 4. Okay, what I like to do personally is I like to make my tables have this little key for myself. So if I see that it has an equal to, I like to box off that 0, meaning it's going to be a filled in circle. If mine has no equal to, it's just greater than or less than, I like to circle that point there, and I know this is going to have an open circle. Okay, now we're just going to go ahead and actually graph these. So I'm going to graph this left one first. So I'm just going to go put a dot at 0, 0, and it is going to be closed because 0 is included. So I'm going to put a closed dot at 0, 0. Then I'm going to go graph -1, -2. Going to go graph -2, -4, and I actually can't fit -3, -6, but close enough. It's down there. All right, what you're going to do is you're always going to start with the dot I graphed first. The arrow will always go away from it. So I want to go to the left of 0 and be less than 0. So I'm going to start here. I'm going to graph leftward. And it will have an arrow because I could have chosen -4, -5, -6. All right, then pick up the other half. So I have now officially graphed half my piecewise defined function. Do the other half. So 0, 1, I'm going to go over to 0, 1. This guy is going to be an open circle. He is not included. And I couldn't include him anyway. He would have 2 points on top of each other, and that would not pass the vertical line test, and it would not be a function. This is a piecewise defined function. It has to satisfy that vertical line test. So you will never have 2 closed dots on top of each other because it wouldn't be a function. Okay, 1, 2. So 1, 1, 2, 2, 3, and 3, 4, and I could have gone and done a 4, 5, and a whatever. Okay, so again, starting at the point that you started at, so that 0, 1, the arrow is always going to point away. I'm going to the right of 0, so greater than 0. So starting here and going this direction. That wasn't great, but it's okay. I have now graphed my piecewise defined function. So it's got 2 points. If I were to graph just 2x, obviously this line would go forever up. If I were just to graph x plus 1, this line would go forever left. But I'm only graphing it less than or equal to 0, and then greater than 0. Okay, so evaluate the function for the given values of x. All right, so f of -1. So where does -1 fall in this graph? And we'll do it both ways, graph and on the function. Well, -1 is here, and -1 goes down 1, 2, so it's -2. Or look in your domain and see which one -1 falls under. Is -1 greater than 0? No. Is -1 less than or equal to 0? Yes. Plug in -1 here. 2 times -1, -2. F of 2. Where does 2 fall? Is it less than or equal to 0? No. Is it greater than 0? Yes. So plug a 2 in here. 2 plus 1 is 3. Also, if I go to my graph and I go to 2, I'm going to be boop, boop, 3. Okay, F of 0. Well, F of 0 actually has 2 spots to choose from. But in the domain, is 0 greater than 0? No. Is 0 less than or equal to 0? Yes. I'm going to plug in a 0. 2 times 0 is 0. Also, the only filled in circle here is 0. Okay, so on your Delta Math homework, you will be evaluating graphically and algebraically. It's very easy. If you just go find the point, like if you know which domain it fits in, you just plug it in. Okay? All right, our next problem, you can see the faint workings of a previous problem. I totally forgot to press record, and I decided to change the problem afterwards anyway. So I went ahead and wrote down the 2 parts just to save time. Okay, I'm going to go through choosing the points again. All right, so this says less than 1. It doesn't really matter what it says, less than or equal to, greater than, who cares? It has a 1, then you're going to put 1 here. Okay, then numbers that are less than 1 include 0, -1, and -2. Okay. It doesn't matter if this says greater than, equal to, whatever. If it has a 1 there, you're going to put a 1. And then, what are some numbers greater than 1? That's 2, 3, and 4. All right, I'm going to show you how to find those points without having to do it in your head each time. Also, you can use that graphing emulator I sent you the directions for. I would definitely download that. You have to have it eventually, but you can use it on this lesson as well. Okay, so I'm going to go to y equals. I'm going to type in the function 2x minus 1, and I'm just going to press second table. I'm just going to go find my points. So 1 is 1, 0 is -1, -1 is -3, and -2 is -5. So do it in your head, do it in your phone. I don't care how you get the points, just get those points on there. All right, so I went ahead and did the same thing and filled out these. I went ahead and went to y equals, I graphed that, and went to my table. All right, so again, we're going to go up here, and I see that this is not included, so it's going to be an open circle. Meaning when I graph it, it's going to have an open circle at that point. Okay, this one also is not included, so greater than is not included, so I'm going to have an open circle when I graph this as well. There actually will be no closed circles for endpoints. All right, so I'm going to go graph 1, 1, so 1, 1, open circle, 0, -1, and these points are always going to be closed circles. Only the endpoints have the option of being open. Okay, -1, -3, and -2, -5. I started at 1, 1, and I'm going to the left. I'm going less than 1, so my arrow is going to start here, and it's going to go to the left of that open point there. Okay, moving over to 1, 2. 1, 2 is open, so I'm over at 1, up 2, and it's open circle. And then I'm at 2, -1, then I'm at 3, 4, and I'm actually off the page at -7, but I'm going to the right of that x, of that 1 rather. So I'm going to be going, starting here, and going down for that. Oopsie daisies, whack the camera. Oopsie. Okay, so we're going to go over here and g of 1. So g of 1, oh man, I forgot to change this question. But it's a good question though. G of 1, if I look over here, g of 1 does not actually exist because I changed it. So it doesn't exist here or here. So g of 1 actually, nice honor Z problem here, has no answer. Sweet. So that's not a point on my graph. 1 does not exist. 0.999 exists, 1.001 exists, but 1 itself is the only point that does not exist. This is no real answer. This is the null set, whatever. Okay, -2. So where does -2 fall in? Well, -2 is less than 1. And I can see that I actually evaluated -2 over here, so it's -5. But you would literally just plug in a -2 here. So 2 times -2 is -4, minus 1 is a -5. Okay, and then the last one, g of 5. So again, go over here. Where does 5 fall in? 5 is greater than 1. Plug in a 5 here. -3 times 5 is -15. Plus 5 is a -10. All right, for our next example, I went ahead and saved time by filling in the 3 parts. Let's go ahead and pick the numbers. So here I have x is less than -2. Automatically, a -2 goes in there. What are some numbers less than -2? Well, that's -3, -4, and -5. And we'll leave those for later. Okay, going over here. The middle one is between -2 and 1. Because I told you -2 is a point, you have to use it. Whether or not it has an open circle or closed circle, if -2 is on that restricted domain, you're going to use it. Conversely, if you have a 1 on the other end, you're going to put a 1 on the other end. You have to pick those 2 points. In between, you can pick whatever you want to. You could pick decimals, I don't care. Just make sure you have -2 and 1, and then anything between there. Okay, and the last one for when f of x is equal to 3, x is greater than 1, so I have to use a 1, and then pick numbers that are greater than 1. So 2, 3, 4. All right, I went ahead and I plugged in the values and find these values, but this tricks people sometimes. So when f of x equals 3, if I plug in a 1, well, I've got nowhere to plug it in, so it's still going to be 3. If I plug in a 2, I have nowhere to plug it in, so it's still going to be a 3. It's going to be a 3. It's going to be a 3. So if you ever have just a straight up number with no variable, it literally is just going to be that number across the board. All right, let's go ahead and do our circling real quick. This guy is open. This guy is equal to, so he's going to be closed. This guy is equal to, so he's going to be closed. So both of these guys are closed. And this guy is a greater than, so he's going to be open. All right, so I'm just going to go ahead and graph these guys. All right, -2, 2 is an open circle. -3, 3.5 is closed. Oh, that's not, yeah, that's right. -4, 5. Boom, I started at -2, and I'm going to the left, so I'm going to have an arrow going upwards. Jumping on over to the next one, I'm going to have a dot at -2, -1, and that's going to be a closed dot. I'm going to have a dot at 1, 2, and that's also going to be closed. And then if you graph the ones in the middle, they're going to be here and here. And it's going between this number and this number. So if you have a middle section, it's going to be a little line. It's going to be stuck between the two. Jumping over here, 1, 3 is going to be an open circle, then 2, 3, then 3, 3, and 4, 3. These will always just be a straight line across, and I started at this 1, 3, and then I'm going to the right because I'm greater than 1. We'll see if we can make it. All right, got them all there. I'm going to pick less than -1, so I have to pick -1, then pick numbers that are actually less than -1. Middle section, I have to pick a -1 because it's on there, and I have to pick a 2, and then in between, I don't care what you pick. I usually just pick the numbers that make sense. The last one is greater than 2, so I have to pick a 2, then I'm going to pick numbers that are greater than 2. Okay, I'm going to go ahead and circle things now and then fill in the numbers. All right, this guy is a less than, so he's going to be an open circle. This guy is a less than or equal to, so he will be a closed circle. This guy is just less than, so he's going to be open, and you need to define bottom and top, whether it's open or closed. And this guy will also be open. All right, so I filled in my points. Let's go ahead and graph it. So -1, -3 is going to be an open circle, -2, -4, and -5. I'm starting at this point. I'm going to the left arrow. Jumping over to -1, -3. Well, -1, -3 is closed, but there's already an open circle there, so just fill it in. Then I'm going to go to 2, 3, and he's also, oh, he's open, sorry. So, and then the points in between would just fit nicely in there. Then 2, 3. I'm going to go over to 2 and to 3. Well, it wants it to be open, so keep it open, and then graph 3, 3, 4, 3, etc., and arrow to the right. Oops. All right, sorry I'm going so fast. If you need to pause or whatever, just do so. Okay, filled in the last 3 here. Going to pick my numbers. So this one says between 0 and 1. So I have to pick a 0 and I have to pick a 1. Pick whatever you want to in the middle, 0.25, 0.5, whatever. Okay, next section. I have to be between 1 and 2. I have to put a 1 and I have to put a 2 on there. Pick whatever you want in the middle. Doesn't matter at all. Last section between 2 and 3, so it's got to start at 2, end at 3. Pick whatever you want. It doesn't matter at all. Okay, this is a less than or equal to, so it's going to be a bracket, or I mean a closed circle, whatever. This is going to be open. Okay, equal to is going to be a closed circle. 2 is less than, it's going to be open. This one, less than or equal to, so closed and open. And this one you can actually see, this is all 1. So it's actually going to be a 1 across the board. This is a 2, and this is a 3. All right, so I graphed 0, 1 as closed, 1, 1 as open, everything between, boom. I'm going to graph 1, 2 as closed, 2, 2 as open, in between. 2, 3 as closed, 3, 3 as open, in between. This is actually called the step function, and there's a definition down here. It just literally means it has steps. We made it!